So now we're going to look at conditional probability. Conditional probability is the probability of an event under the condition that some preceding event has occurred. So to find the probability of A given B, you would find the probability of A and B divided by the probability of B. To find the probability of B given A, you would find the probability of B and A divided by the probability of A. And again, a lot of that does not make sense until you see it in an example and you realize that most of the time it's not quite as complicated as it looks or sounds. So we're going to look at this example of boys versus girls and whether they like tennis shoes or slides. So we're going to find the total. So for boys, we had 9 who like sneakers and 3 that like slides. So that's 12 total. For girls, we had 2 who like tennis shoes and 6 who like slides. That's 8 total, giving us a total of 20 students that were surveyed. 11 prefer sneakers and 9 prefer slides. Okay, so let's answer some questions. Find the probability that they prefer slides. All right, well, slides was 9 out of 20 students. Doesn't simplify, that's it. Probability of a girl, there were 8 girls out of the 20 surveyed, so that does simplify to 2 over 5. Slides and girls, so for this one, you want to look at the slide column and the girl row and see how many girls liked slides, and that would be 6 out of 20, which simplifies to 3 out of 10. Slides or girl, and the or can be a little bit tricky, so we need to find what's the probability of slides, what's the probability of girl, and then because there are girls who prefer slides, we need to subtract this out. So this is an overlapping event. So the probability of slides is, where's slides? 9 out of 20. Plus, or means plus, the probability of girls is 8 out of 20. But then we need to subtract out the girls who prefer slides, which is 6 out of 20. So 9 plus 8 is 17, and 17 minus 6 is 11. So 11 out of 20 would be our probability for someone who prefers slides or is a girl. For E, it's the probability of slides given that it is a girl. So we're looking for, and this is what that formula on that last slide was, we're looking for slides and girl over girls. Okay, so how many slides, how many people were girls that prefer slides? That would be 6, and then how many total girls are there? 8, so 6 out of 8 or 3/4. What's nice about this is whatever, kind of think of this as your division symbol, so girl should be in the bottom. Whereas F says find the probability that it's a girl given that they like slides. So this time we're looking for girl in slides, but this time over slides. So there's still 6 girls who like slides, but out of 9 people, because there are 9 people who prefer slides. So again, that second thing is going to be your denominator. So 6 out of 9 is 2/3. Probability of sneakers, okay, just plain old sneakers, there's 11 total out of 20, doesn't simplify. And the probability of sneakers and slides, well, there's nobody who fits into both of those categories, so that would be 0. These ones can be a little bit tricky. But once you kind of get the formula down, it's not terrible. It's just understanding how to read the problem and pull the right number. So it says, in New York State, 48% of all teenagers own a skateboard, 42% of all teenagers own rollerblades, and 39% of all teenagers own a skateboard and rollerblades. What is the probability that a teacher owns rollerblades given they own a skateboard? So we're looking for the probability of rollerblades given that they have a skateboard. So if we go back to our formula, it says to do this, we have to do the probability that they own rollerblades and a skateboard over the probability of a skateboard. Again, whatever comes second, that's going to be your denominator. So our probability that they own rollerblades and a skateboard is 39%, and we can just leave it as 39. And then out of the probability of a skateboard, that's 48. So 39 over 48. That does simplify to 13 over 16, and I'm completely fine with you leaving it like that. Some people like to change that to a decimal, so you could potentially turn it to a decimal, which would be 0.8125. But I'm totally fine with you leaving it as 13 over 16. All right, example 3 is similar. Again, you got to read really carefully to figure out what it is you're trying to find. So at a middle school, 12% of all students play football and basketball, 20% of all students play basketball, and 32% of all students play football. What is the probability that a student plays basketball given that they play football? Okay, so to do this, we have to find the probability of basketball and football over the probability of football. So the probability that they play both is 12%, and the probability that they only play football is 32%. So 12 out of 32, which simplifies to what? 3/8. So I'm fine with 3/8. If you want to write it as a decimal, 0.375. Proving independence. So sometimes, and we talked about independent versus dependent in the previous lesson, you know, independent is when one thing doesn't impact the other, but sometimes it's not as obvious as some of the examples that we did. So we can prove independence by finding the following 2 things, or technically 4 things. And if they're equal, then we know it's independent. So if the probability of A given B is equal to the probability of A, and the probability of B given A is equal to the probability of B, then we know that the events are independent. So let's look at some examples of that. All right, so another 2A table, you may remember doing these last year, born in Georgia. How many people were born in Georgia? Well, we have 7 male, 5 females, so that's a total of 12. How many people were not born in Georgia? 16 male, 13 female, that's 29, giving us a total of 41 students. All right, how many are male? That's 23. And how many are female? That's 18. And just making sure 23 and 18, also 41. Good. All right, so probability of male. All right, well, how many males are there? There's 23 out of 41. That does not simplify. Born in Georgia. All right, born in Georgia, there are 12 out of 41. Okay, so now we're going to find the probability of male given that they were born in Georgia. Okay, so that means we need to find the probability of male and born in Georgia, and then divide it by the probability that they were born in Georgia. So we're not doing this out of all 41 people. We're looking just specifically at the probability that they were born in Georgia. All right, so male and born in Georgia is 7. And how many people were born in Georgia? 12. 7 over 12. Okay, now we're going to do the opposite of that. Now we're looking for the probability that they were born in Georgia given that they're male. So we still had to figure out the probability of they were born in Georgia and male. But this time we're looking out of all the males instead of all the people born in Georgia. So male is our denominator, whereas the last one, born in Georgia, was the denominator. So still 7 people that were male and born in Georgia, but now we're looking out of all the males, which is 23. Okay, so are male and born in Georgia independent? And the answer to this is going to be no, and that's because the probability of male does not equal the probability of male given they were born in Georgia. And likewise, the probability that they were born in Georgia did not equal the probability that they were born in Georgia given they were male. Okay, so these two are not the same, and these two are not the same. If they were the same, then they would be independent. And one of the things that, like, some people are like, oh, there's so much to, like, remember in this. Keep in mind, male, male, born in Georgia, born in Georgia. Those two things go together. All right, so let's look at another one of these. All right, and we're just going to decide, are these events independent or not? So the event odd and the event of 3 or 6. So let's talk about, and this is from rolling a 6-sided die. So odd, right? How many odd possibilities are there? Well, there's 1, 3, and 5. So that's 3, and it's a 6-sided die, so 3 out of 6, which simplifies to 1/2. Okay, what about the probability of 3 or 6? Well, the probability of 3 or 6 would be 2 out of 6, which is 1/3. Okay, now let's look at the probability of odd given it's a 3 or a 6. Okay, so we're looking at the probability of odd. Oops, hang on one second. So the probability of it being an odd value, if it's a 3 or 6, well, 3 is odd, but 6 is not. So you have a 1 in 2 chance of it being odd. Now we're looking at the probability of it being a 3 or a 6 if it's odd. Okay, so if it's odd, that's 3 total numbers. And it being a 3 or a 6, well, 3 is odd, so that's only one possibility. So now if we look at odd given a 3 or 6, those are equal, so that's looking good. And then 3 or 6, and then 3 or 6 given it's odd, that is also 1/3. So because these are equal to one another, then this is independent. And again, that's because the probability of odd equals the probability of odd given a 3 or 6, and the probability of 3 or 6 equals the probability of, running out of room, 3 or 6 given it's odd. All right, let's try another one of these. So now the two events we're looking at is even and prime. So let's start by finding the event that it's even. So even is kind of like odd. There are 3 possibilities, 2, 4, 6, 8, right, which is 1/2. Okay, so then it says find the probability that it's even given you've rolled a prime number. Okay, so let's go through, let's make sure we know what your possibilities are for prime. Prime is 2, 3, and 5. Okay, a number where it has no other factors besides itself and 1, and 1 is not a prime number. So given that it's prime, you have 3 options, and of those 3 options, only 1 is even, so that would be 1/3. So the fact that those two are not the same already tells you that these are not independent. These are going to be dependent because they're not equal. But we'll go ahead and finish the other ones too. The probability of prime, okay, well, that's 3 out of 6, which is 1/2. And the probability of prime given that it's even. So your even numbers are 2, 4, 6, and 2 is an even number, so that's only one of those 3 is an even number. So be careful on this one because you might see, oh, well, those are both 1/2 and those are both 1/3, but the order here is really important. These two have to be the same, even and even given prime. And then same thing down here, these two have to be the same, prime and prime given even. And since they're not, it's dependent. So probability of even does not equal the probability of even given prime. And it's got to be true for both. probability of prime does not equal the probability of prime given even.